Good day everyone, my name is Dr. Dirk Kukemoer and today I'm going to explain to you how to test a patient to determine the thresholds at different frequencies. So on this screen you will see there's an audiogram with a cursor on the audiogram here that I can move around by pressing right and left. That's going to a higher frequency if I press right and to a lower frequency if I press that button. I then can go louder by pressing the down button and go softer by pressing the up button. So to go into manual mode, you have to press the pause button. That is how you get control over the buttons on the right hand side. If you want to go back to automatic mode, you will press the auto button and the test will continue where you finished with your manual test. So while I'm talking here, you will see those irritating bars popping up and down. Those bars are the bars that's monitoring my voice as I'm talking to you at the moment. So if I talk loud like this, you will see the bars pop up. If I'm quiet, the bars will disappear. So these bars are frequency specific. It measures the ambient noise in real time in octave bands. Interestingly, it doesn't measure the average like a typical sound booth gets certified for. It measures peaks. So if a door slams or someone talks loud outside, it will pick up the peaks, not the average. These bars represent the noise that's at the ear, not the noise that's at the PC, at the ear. So there are multiple microphones built into the Goodwave inside the cup and outside of the cup, monitoring the ambient noise. So if my cursor is currently here at 1000 Hz, 30 dBs, if that cursor is for instance here at 0 dBs, 1 kHz, you will see noise too loud pops up here. It's because that bar goes over my cursor. If I keep quiet, that bar disappears and you will see on the right hand side this noise too loud also disappeared. So when you're doing a test, you can only present a tone if that bar is not over your cursor. So if I'm going to present a tone, argument's sake here at 20 dBs, that bar, as I'm talking here, is below my cursor, or I mean above, softer than my cursor, and you will see I can present a tone because it says they're quiet enough. If it goes very noisy like this, oh, now I can't even get there, then the bar will indicate to you that you cannot test. So currently I'm on 1000 Hz at 20 dBs. On the right top hand side you can see 1020 dBs. Those two values, 1000 and 20 dBs, are the values that you as an audiologist are used to look at. Now on the Goodwave, you look at the audiogram itself. You keep your eye on the audiogram and you look at the cursor, and that is where you test. So I can go louder here and I can decide I can go and present a tone at 50 dBs, 1000 Hz. You see that button there? It's a pure tone. Beep, it will present the tone. So when it presents the tone, it waits for the patient to press the button. You see, in this case, the patient didn't press the button. The thumb is down. So I'm going to present the tone again now. Ah, there the patient pressed the button in time. I'm going to present again. There the patient pressed the button in time. So what you will see here, there are two green dots here and two orange dots. And there you can see there's an orange dot. The orange dots mean the patient didn't press the button because he couldn't hear the sound. The green dot means the patient did hear the sound and press the button. I'm going to jump up here. See, there it's now very noisy. As I'm talking here, I'm now going to present a tone and you will see what color button will pop up there. See, that is a yellow dot. A yellow dot means the patient didn't press a button, but the reason for it, because it was too noisy. So you cannot trust that tone that was presented. You will have to redo it. The Goodwave records whether it was too noisy at that moment. If a patient, for instance, I'm just going to jump to this threshold, 1 kHz 20 dB. If the patient presses a button and no tone was presented, a grey dot pops up. That's a false positive response. Means the patient should not have pressed the button. So if you, for instance, get like multiple false positives like this in a row going up, it means this patient constantly press the button, just press, and then that will start happening. If you see that happening, sorry, you cannot do a test. So I'm going to jump to here. I'm just going to mark a threshold. I can mark a threshold there. Now it's obvious that's an incorrect threshold. Let me jump to 2000 Hertz and let me start testing this patient now officially on this threshold. I'm going to present the tone, beep, and you will see the patient didn't press the button. So I will go louder with 5 dBs, present the tone again. There the patient pressed the button. Go softer 10 dBs. I use a use and Westlake method, present the tone, patient is not pressing the button. I will go louder, 5 dBs, present the tone, patient doesn't press the button. I will go louder, another 5 dBs, present the tone. The patient pressed the button. So there you see it. It's obvious that is where I have to mark the threshold, and I will, there I pressed another tone, but I will mark the threshold here. Then I can jump to 4000 Hertz. I will present the tone, the patient presses the button. I go softer 10 dBs, present the tone, the patient is not pressing the button. Go louder, present the tone, patient doesn't press the button. Go louder, present the tone. The patient pressed the button. When the patient presses the button, I can mark the threshold here. If there's a no response, for instance, I go down here, and the patient didn't press the button here, there present the tone, patient not pressing the button, present the tone again, patient not pressing the button, I can mark a no response there. You see the arrow is down, no response. The good wave also have an up arrow, that is for minimum plateau. Now what minimum plateau means is I annotate that I didn't try to test softer than a certain frequency, than a certain threshold. For instance, let's say I'm there. Let's say I decide I'm not going to test softer than 10 dBs. I will test the patient when I get to 10 dBs and I present the tone and the patient presses a button, present the tone, the patient presses a button, I'm finished. I don't want to go and test 0 dBs or 5 dBs. I will then annotate that is a minimum threshold that I tested to. Now why is that important in the kudu wave? Let us jump to an area where there's some noise bars at the moment. So let us say I tried, it was very noisy. I tried to test down to 10 dBs, but I couldn't because those bars constantly popped over. So I only could get down to, argument's sake, 15 dBs because the noise was too much. What I will do is, I will then say minimum plateau there. I annotate that it was too noisy at that stage. So it's good to know it was too noisy. Then you've got information that you can use that information to interpret the test results. If it's important to actually test quieter, to lower thresholds, then you have to redo that test. But usually you have to decide clinically what the different thresholds, if they could not, for instance, get to 0 or to -10, what the effect will be on your clinical diagnosis. If I want to jump over to the right side, I will press the R button here. Then it goes red, the screen. But you see, you will still see the blue audiogram here. So it's all still visible. I can jump to the left side. I jump to the left side. You see. Currently I'm on air conduction, and you see there's a big blue, light blue space here. I can go down to 110 dBs and present tones here. So what I'm just going to click on 30 dBs. If I click on bone conduction, you will see that area decreases significantly. I can only present frequencies up to 4 kilohertz, and I can't go louder than 60 dBs in the mid frequencies. So you're limited to maximum thresholds that you can present to. For here, for 250 hertz, for instance, it's 40 dB, the maximum threshold that you can present to. I will go back to A, and I come back to air conduction like this. Now, let's jump to the right side. I'm just going to mark a few thresholds here. Mark the threshold there, mark the threshold there, mark a threshold, mark a threshold. Okay, so if I want to present a tone now in the left ear, and let's say I go very loud here, and there's a difference of 60 dBs between the left ear and the right ear, I don't have to do masking, because the interaural attenuation of the Kud wave is significantly more than a supraaural headset. You typically only start masking when you get more than 70 dBs. So if I go louder, now I'm at 80, let's get to 90. So now there's more than 70 dB difference between the right ear and the left ear. Then I will introduce masking. How do I introduce masking? I introduce masking by pressing this button down here. You'll see it's red. Means I'm going to introduce masking on the red side to the right side. I'm now on the blue side. I'm going to do contralateral masking here by pressing this button down, and there you can see now I'm masking 20 dBs above the non-test ear. So interaural attenuation will have no effect here. It will present the tone, and the patient will not hear the sound on the right ear. Okay, if I'm finished with masking, I can press the home button. I can go, let's just example again, there I can add masking, I can decrease masking, and I can mute masking. If I, for instance, decide I want to mask here, I can click here, right click and say mask contralateral here. So I don't have to press that down button all the time. Just say mask contralateral here, and here you see I'm masking. So this zigzag means masking at 70 dBs in the contralateral ear. If you want to mask there, right click there, and I say mask contralateral here, and there you see I'm masking there at the moment. Then I go and press mute. I can also do UCL and MCL tones. Let's say I'm there, I want to present a tone here. The patient says this is too loud. I can go to MCL there, and I can mark a threshold MCL. I can go to another one, argument's sake. Let's say I tested that's the MCL. There you have it, 2 MCLs. I can also do UCL, uncomfortable level. Let's say there, and you will see I will mark it there, and there you can see this is how the annotations look like for uncomfortable, and that is for most comfortable.